Okay, today we are on Unit 3, Lesson 12. We're talking about tenths of a centimeter. So our math message today is our warm-up from our workbook, page 98, 98. So it says, number 1, cut out the ruler given to you by the teacher, or just use the ruler that I've given you. Use it to measure the pencil to the nearest centimeter. So remember, our rulers have inches sides and centimeter sides. We need to make sure the centimeter side is up. So at the 0 spot, it says cm. We measure from the eraser to the very tip. Lining that up. I'd say that is about 11. We'll kind of just go to the nearest, oh, yep, it says go to the nearest centimeter. So it's over the halfway mark for 11.5, so we'll just say 12 centimeters. Pencil A is about 12 centimeters long. Pencil B now, we're going to measure B, eraser to tip. That is also about 12 centimeters long. It's not quite half, so that's why we're just going to go with 12. Okay, one pencil is longer than the other. Which one was longer? Well, this one was a little over 11.5. This was less than 12.5. Pencil B was longer. How did we figure it out? Well, pencil A was closer to 11.5 centimeters, and pencil B was more than 12 centimeters. Marco wants to know the difference in length between the two pencils. Can you tell him why or why not? Yes. Okay, and now it's your turn to explain the difference in the length between the two pencils. Okay, oh, we forgot to add up here. How did you figure out which pencil was longer? I measured using the ruler. Okay, so can you tell him why or why not? Yes, and now this is your turn for your explanation. Number 5, use the centimeter millimeter ruler to measure the pencils to the nearest tenth of a centimeter and millimeter. Okay, those millimeters are actually they're tenths of a centimeter. Okay, so when we actually measure this out, pencil A, we're going to figure out how many. So we got 11, and now we're going to count these little tiny teensy weensy lines. Okay, those are millimeters. So if we counted, here's 5, 6, 7. So pencil A is 11.7 centimeters long. So I'm copying that down for our number 5, 11.7 centimeters long. Or if we counted all these little tiny lines that get us to 11.7, that would be 117 millimeters. Okay, please pause the video, measure pencil B, just like we did A now. Unpause when you are done. Okay, welcome back. We are on B. So B, we said, is a little over 12. 1, 2, 12.2. So 12 and 2/10 of a centimeter, or 12 and 20 hundredths, same thing. So that would give us 122 millimeters. So pencil B is blank centimeters or blank millimeters longer than pencil A. So now we would just take 122 minus 117. Pause the video, solve, fill in these two sections when you're done. Okay, can we take 7 from 2? Nope, so we've got to borrow. The 2 becomes a 1. This becomes 12. 12 minus 7 is 5, 0, 0. So 5/10 of a centimeter or 50 millimeters, or 5. Got to bring down our decimal place. Or 5 millimeters longer than pencil A. Okay, we're going to continue on to page 99 in our math journal. Use the scale at the left and map on page 284 of the student's reference book to draw a dot to show the amount of precipitation for each of the following cities: Los Angeles, Chicago, Oklahoma City, and Mobile. Write the name of the city next to the dot. So what they did is they did Topeka for us already. Please open up your math book page to 284. Okay, we are using our graphic source, page 284 in our math book, to find these different cities. So Los Alamos, okay, that is here in Arizona. It says there's 5.1 centimeter of rain that year. Our next town is Chicago. It's in Upper Illinois. Here's North Dakota, South Dakota, Minnesota, Wisconsin, Chicago. Iowa's over here. And it says 8.2 centimeters. Our next one, Oklahoma City. Right above Texas, 10.3 centimeters of rain or precipitation. And the last one, Mobile, is over here, 12.9 centimeters. Okay, we're going to use that information. Now, I've written it on the bottom here. Oh, Topeka, Kansas, that was the last one. Topeka, Kansas was above Oklahoma City. Here we go, 9 and 3/10 of a centimeter. Okay, so I've written those below already for myself as reference on our page. Now what we're going to do, we are going to write the name of the city next to the dot. So Topeka's already been done at 9.3, so they went all the way up to 9 to the third dash, 1, 2, 3. And they did a dot and wrote Topeka. Now we will do the same for Jacksonville. Jacksonville is 20.8, so we go up 20. The halfway mark is 5, 6, 7, 8. Do a dot, we write Jacksonville. Please pause the video and do the same. I'm going to switch colors so it's easier. Okay. Next we will do Oklahoma City. and the others. So I would like you to do that. So Birmingham, 9.9. Birmingham San Diego is 0.4. So we go 1, 2, 3, 4. San Diego. Okay, I'm missing a couple. I'll do those while you are finishing up as well. Okay, so I've written them in down below here, and then you can chart them. So mobile is 12 and 9/10. Oklahoma City, 10 and 3/10. And Chicago, 8 and 2/10. Please chart those out and check them off when you are done. Okay, now that we've checked those off, we can use this information to help us. So which part of the country had the most rainfall in September when we have this map open? So September. Well, it looks like Jacksonville, Mobile, Oklahoma City. So let's look at those spots on our maps. So Oklahoma City, Jacksonville, and Mobile. So we could go southeast. That's what we could say. Sorry, I thought I had this here. So we've got Mobile, Jacksonville, Oklahoma City. That was our top 3 on our gauge here, our rain gauge. So that's how we knew that. So we will say southeastern. Which parts of the country have the least? Okay, so let's go down. We've got San Diego and Chicago, but San Diego's way, way down there. So we will use San Diego. Southwest or Salt Lake was just 3.1. Even though we weren't really looking at that one, you can tell we've got 4/10. 5.1, 3.1, then we get more and more. So the southern part, southwest. We could also just say west in general because we have 3.8 here, 3.1, 5.1, because Seattle is the west, but it's not the south, it's the northwest. So we can just say west. So south and west for our directions. Which city gets about 5 centimeters less precipitation than Mobile? Well, Mobile had 12.9. So 12.9 minus 5 is 7.9. So which one has about 7.9? Not Seattle, not Salt Lake, not San Diego. No, no, no. 7.9 on the dot, Indianapolis. Which city gets about half as much precipitation as Oklahoma City? Oklahoma City had 10.3, so half would be about 5.1 or 5.2 would be half. So that's what we're looking for next on our precipitation chart. 5.1 or 5.2. 5.1, Los Alamos. Which city gets about 3 times as much as Salt Lake? Salt Lake City had 3.1. 3 times 3 is 9. 9 times 1 is, or I mean, 3 times 1 is 3, so 9.3. We're looking for a 9.3. Topeka. Oklahoma City gets about 2 times as much as Oklahoma City. Which one? So Oklahoma City gets 10.3. 10.3 plus 10.3 is 20.6. Oh my goodness, that is a lot. 20.6. I'm going to go to the southeastern part because that's what we learned earlier, that they had the most. 20.8 is our closest with Jacksonville, Florida. Okay, so we have taken all of these centimeters and we've practiced today plotting them on a ruler where our centimeters lie, using centimeters and millimeters today. So that was good practice. Now, page 100 is extra practice on reviewing quadrilaterals and triangles. So we're going to do this really quick. I would like you to actually try this on your own since it is a review, and then you can unpause the video. We are on page 100. Unpause the video and check your answers. Thank you for pausing. Here we go. We're circling the polygons that have 2 sets of parallel lines, 2 lines that don't cross. So you could go this way. You could even have them diagonal, vertical, horizontal. So this one, both sides are parallel with each other. That works, that works. This would not work because they would collide and intersect, so that would not make it parallel. Circle the triangles that appear to be right triangles. This one has a right angle right here, so that makes a right triangle. This one has a right angle, and no, and no. Circle the shapes without parallel sides. So this is a parallel side. This one's not, so that does. Okay, so these are without because they intersect, these next 2. And our last one, circle the shapes with perpendicular sides. That's where you have one bar going across and the other at 90-degree angles. This is perpendicular. Perpendicular edge here, yes. And perpendicular. There's a perpendicular, and these 2 are perpendicular. Okay, then you get to make up your own 2 polygons. And that is our lesson 12 for Unit 3. Bye.